right, good day all. Now we are going to look at power dissipation in a transistor. Okay. Now let's ask, this is a transistor, and if you switch on this transistor, what will happen is like you switch this on, all right, current will start flowing through there. If you want to measure the voltage between this point and that point, the voltage will be zero because the whole of this will be at the same potential. But if you switch this on, off, if it is off, now the voltage between this point and this point will be different because this will be at VCC and that will be at, if this is very small, that will be at 0. All right, so the voltage across will be VCC if the switch is on. Okay, so let's use that to analyze this. Now this is a signal going into the base, okay, to be able to switch this on. So it's 1, 0, 1, that is on, off, okay. Now as we switch this on and off, on and off, on and off, all right, now from the time of on, if you check the time from here to here, plus the time of off, that gives you a period. So you have a period on, off, before another on. So from here to here is a period, T. So if you want to get the time of on only, the time of on, you say that is the duty cycle, all right, multiplied by T. All right, for instance, if this is half, from to here is half of this, it means that the duty is 50%. Okay, duty cycle in that case is 50%. That means half of the period is 50% on, and then 50% off. Okay, for that period. All right. Okay, so I will explain more about the duty cycle. So just have that this is T on equals KT, and then this T off, the time of off, T off, is 1 minus K, all by T. So where K is what we call duty cycle. All right, so I'll explain more on that. Now, so it means that this switch will switch on, off, on, off. Let's see now the voltages and currents, okay? Now let's look at the voltage first. If I switch this on, if I switch it on, what happens to this voltage? The voltage across here will be 0. All right, if I switch it off, the voltage will increase, will be VCC. All right, so now, when it was off, okay, the voltage is VCC, but immediately you switch it on, now the voltage has to decrease, will be 0. So I was supposed to get the voltage here to be 0 immediately you switch it on. But this switch doesn't work that way. It's not an ideal switch. It has to take time. So that is why here I switch it on. This is supposed to be 0 immediately. But remember that from the previous state it was off. So the voltage was VCC. So it will take time, all right, for the voltage across this to now decrease, okay, to almost 0. But still, it's still going to saturate. It's true that you've closed it, all right, but there will be a small amount of voltage across this that we call the saturation voltage, okay, VCE across the C and E. This is a meter, and that is a collector. Okay, so it is going to saturate. It's supposed to be 0, all right, but it should just be a small amount of voltage, all right. So that is a V saturation. Now that is when this is on. So when this is on, the voltage is 0. Okay, but in this case we have saturation voltage. So now immediately you switch it off. You switch it off. What happens? The voltage is supposed to move, increase straight to VCC, but it has to rise gradually. All right, rise gradually, and then before it gets to VCC, and then the cycle continues. All right, the same thing, the current. the current is going to start rising once you switch this on, all right? But it will not immediately you switch it on. It will take some time. There will be a delay before it will start rising up, okay? So it start rising, and then until it gets to full, the maximum current, ICE, and then like that. Now, when you switch off, the current has to drop, okay? It falls till it gets to 0. All right, but it's true, sometimes when it's off like that, all right, then there might be some leakage current. That's your ICE, which is leakage current. All right, so now let's see how do we get the power, because we want to look at the power dissipated at this transistor. So how do we get the power? Now we say that power is a voltage times time. All right, so that is power. So if I have, I'm going to integrate the whole of that. So I'm going to multiply this voltage times this time. All right. So now, and if I integrate that with respect to t, then I can now divide with the period. All right. So I need to do it for this one period. So what I'm going to do is, just to make it simple, I'll say, okay, I can get the power. Okay, the power, you see here is energy. Once I put time, IVT, then it's energy. So now I have that total energy just for this time of rise is just this current multiplied by this voltage. So you just need to know the equation, okay? Now, so we'll look for rise. Now let's just call this fully on. For fully on, let's just say it's on, okay? So we'll call it on. So it will be this voltage here, current here, multiplied by this voltage there. And later we take this also, multiply by that, okay? And then just like that, we continue. That's why I'll take it this way, E off plus E on plus E rise plus E fall. All right, so I'll need to get E off, okay, which is the whole of this when it is off. Remember here, this section, when it is off, the voltage increases, all right, when it is off, all right, here. So, but now I just want to take from here now, all right, so this is the whole off. Now later, I now add it with E on, which is from here to here. All right, I add it with E rise, this one, and then E for that one. Okay, you get that? Once I get the whole of that, divided by this period, that gives you the power. All right, you get that?